Okay, so a couple things about what they told us here. 10 meters high, that is this distance. So if I set this guy at 0, 0, I would go up 5 and down 5 to get to the highest points that thing would rise from the bottom. Focal length. The focal length is where your focus is. So on a regular parabola, that's just called a focus. But when they're talking about a satellite focal length, they're actually talking about where all these guys come together at one point. So equidistance from that focal point means that's where the receiver is going to receive all of those signals. So that's that point away from that vertex where it's going to receive those signals. Okay? So, and they've given you a really nice diagram to show you what that looks like. So if I set this guy on a 0, 0, and they've given me a focal length of 3.2, this is my X value, right? So it's going to be, my focus is going to lie at the point 3.20. That's where this guy is going to be, right? Because I've moved right 3.2, and I haven't moved up or down. On my x equals y squared type function, which is what this is, if it's sideways like this, then my focus is h plus p. So if this is h plus p and h is 0, this actually automatically tells me what my p is. My p is 3.2 as well. So now I have everything I actually need for my function. I have my p, which I can figure out my a from, and I know my h and k. So if I were to set this up in standard form, it's going to be x equals 1 over 4p, y minus k squared plus h, right? So in this case, my h and k are 0. So it's going to look like this. X equals 1 over 4 times 3.2 y squared. All right. They want me to tell them how high this gets. Well, if I know, think about, this is flipped. So normally if I know my x, I plug it in and solve for y, but this is an x equals equation. I know my y, I can plug it in and solve for x. Either one of these will give me the same answer, whether I put in positive 5 or negative 5, because we're squaring it. So I could just say 1 over, and this is what, 12.8, 5 squared. And that gives me 25 over 12.8, which I think they actually put that in as a decimal, whatever the decimal may be, 1.95. Yeah, so when you plug that in, you should get approximately 1.95 meters is the highest point of that dish. So a couple things about an ellipse. First of all, the definition is a set of points in a plane such that the sum of the distances from the two fixed points is its foci. All right, so we actually have, when you think about a circle is a set of points equidistant from one point. Okay, an ellipse is actually a set of points that are equidistant to a point, really, from two is what you're trying to think of. So the best way to do this is you have two fixed points. So let's say we have two nails on a board and we have a string that goes to all of them, and you put a pencil in the string and you draw around, you will create an ellipse. The closer these two get to each other, the closer you get to a circle, by the way. So if these two are close, in fact, if they're infinitely close, they end up being the same, and you have a circle because you have just one string that's making you go around. The further away they get, the more stretched out this oval type shape is. So an ellipse you can think of as like an oval because you have two sets of points that create this shape, all right? And so a couple things that happen with ovals different than a circle. Circles are equidistant from one point. Since we have 2 points, then you have an elongated. So you have a major axis, which is the longer of the two. You have a minor axis. You have the two foci, right? The focal points here, because those are the two that are creating it. You have 4 vertices. So you have 2 regular vertex, like a vertex 1, vertex 2, and then you have what's called covertex. Okay, those are what lie on that minor axis. So you can think of the furthest point away on the major, that's the vertex. The furthest point away on the minor is the covertex points. Okay, that's what creates an ellipse. How then do we find this guy? So we're going to talk about the standard form of an equation. So on the major axis, you have the A length. It's going to be the same on either side of your center. Your center is still HK, so that's nice. That's what it is on my parabola. All right, my vertex on my parabola is HK. The center of a circle, when you look at a circular equation, is HK, and the center of an ellipse is HK. All right, so those stay the same. Your A is on your major axis. Your A is your distance away from your center to your vertex. And it is going to be the same in both directions, but you'll notice that to go left, you subtract the A, and to go right, you add the A. That makes sense, all right? On the minor axis, you have your B. Your B is your distance away from the center on your minor axis. And so to find that, you're going to keep your H the same, and you're going to do your K plus B, keep your H the same, K minus B. And I will say, and we'll look at this when we look at the two ways, it depends on where your major and minor axis lie. So if your major axis lies on your X, on a horizontal, then your X value is what is going to be changing, all right? Versus if your major lies on your Y, then your Y would be changing, okay? So that's, you've got to think about it this way. I will say A is always your longer length. So you don't always have the B going with the Y. You don't always have the A going with the X. It depends on which way the sky is lying on the coordinate plane. All right, so A always follows the longer side, the longer axis. It always goes with the longer one. All right, let's look at this. So C is the value that where you are away from the center to your focus, all right, to each of your focal points. So you'll notice that this distance is C. When you actually do this, you will actually see that you create this right triangle with your focus to your center, up to your minor axis. And then if you were to take your major axis length right here, you would get the hypotenuse of this triangle that's created. So a couple things happen in this process. One thing I want to point out, this guy is elongated on the X axis or on the horizontal. So you'll see that the A is underneath the X piece of it. All right. So these are the standard form of the equations. They are identical. The only difference that is between these two is where that A and B are. If they're elongated on the X, the A squared's under the X, the B squared's under the Y. If they're elongated under the Y, the A squared's under the Y, the B squared's under the X. You'll notice, unlike your parabolas that flip-flop, your H and K do not change, okay? So your H and K remain with the X and the Y, no matter which way you're elongating. It just depends on where that major axis is sitting, okay? So that's the only thing that changes between the two. And then we're going to look at some of the differences. The horizontal here is Y equals K. So Y equals some value creates your horizontal. Your vertical is X equals because it's going this way. Your vertices, these are your major vertices, not your co-vertices. You'll notice when it lies on the X that your X value is H plus A and K. But when it lies on the vertical, your Y value changes. It's going to be the K plus the A, and the H stays the same, which is logical, right? Your vertical on this way is going to be your X, and your horizontal is going to be your Y equals K. Co-vertices, when it is the short side here, then your Y value changes with your B. When it is the short side here, then your H value changes with the B, okay? So that's all that's happening here. And then we have our foci, which are these guys right here. You'll notice that on the X changes. On the Y side, the Y changes. So you just have to realize which direction you're going, which is your major and which is your minor axis, to know which one you're going to use there. Something else I want to point out, and I think it might be hidden somewhere in the terminology here, but we'll talk about it. If this happens right here, then if I have any two of these, if I have A, B, or C, then I can find my hypotenuse. I want to warn you, on a standard Pythagorean theorem, it is A squared plus B squared equals C squared, okay? But that's not true of this. So this is gonna kind of flip your thinking. A is your value of your major axis, B is the value of your minor axis, half length, okay? C is your distance from your center to your foci, to your focal points. So it's not going to be a squared plus b squared equals c squared. It is actually flipped around. Your a is your hypotenuse here, which is very confusing sometimes because you're naturally going to put your Pythagorean theorem that you've always thought of. But you have to think of Pythagorean theorem just means your two shorter sides squared equals your longer side. In this case, your longer side is your a. What you're going to be using most of the time here is actually going to be that c squared equals a squared minus b squared. Your c value here, which is your distance from your center to your focal points, is going to equal your major axis length squared minus your minor axis length squared, okay? And so that's what you're going to want to remember versus your a, b, and c, because that will throw you off. All right, so let's look at some of these examples. All right, so some things that you want to know when you have a graph. You want to know your vertices and your covertices, right? Because that's the distance away. If it's in standard form like this, your center is handed to you, just like it is in any standard form typically of any of these. So if I look at this first one, I need to think about the fact that my original equation is over the things squared. So when I look at this guy is actually 5 squared. This is 3 squared because my a is the piece that is being squared. All right. So immediately when I have this, I know where my major axis is. My major axis is going to be with my x. It's going to be elongated. Okay. So you want to start labeling a few things. Your center is HK. Your original equation is both subtraction. So my center here is going to be at -3, 1. Okay. And then I need to find my vertices. Okay. My vertices are going to be starting at this center point and going left and right on my major and up and down on my minor. Okay, so I typically label these V1, V2 for my major, V3, V4 for my minor. All right, and so my major V1, which is going to change, my X or my Y value here? Well, my longer axis is on my X value is going to change. So I'm going to take this, I'm going to leave the Y value alone, and I'm going to add 5 to my X value, which will give me 2, 1. And then I am going to subtract 5 from my X value, which will give me -8, 1. Those are my vertices, all right? Then I am going to find my covertices. Those are my minor ones, which means now instead of my X value changing, my Y value is going to change. So for my V3 and my V4, my X value is going to remain -3. My Y value is going to change based on my B. So my B here is 3. I will add 3 to my Y value. I will subtract 3 from my Y value. Fairly simple, okay? It also wants me to find my focal points, all right? So focal points are a little bit different. In order to find my focal points, I need to find my C value, okay? So this is where you're gonna use that C squared equals B squared minus, or A squared minus B squared. So C squared should equal A squared, which they handed to me, that's 25, minus B squared, which they also handed to me, which is 9. So my C value is the square root of 16, which is 4, okay? My focal points are also going to be on my x-axis because that's where my major axis is. So I have 2 focal points, remember, because this is an ellipse. So I have F1. Again, my y value is not going to change. I'm going to add 4 to my x value, which is going to be 1. And then I am going to subtract 4 from my x value, which is going to be -7. So really I have all the pieces that I need to sketch this ellipse, all right? I'm going to start at my center. My center is -3, 1. All right? My major vertices happen at 2, 1 and at -8, 1. My minor happen at -3, 4 and -3, -2. And you can see that we're starting to form what will look like an oval, right? And they do want me to graph my focal points. So I'm going to graph my 1, 1, and my negative 7, 1. So here's the thing. If I were to put strings around those two focal points and get a pencil that went out to any of my vertices, it would draw that oval. We are sketching it, so you are free to just sketch the oval as pretty as you can, right? Beautiful oval. Isn't that gorgeous? So something else I want to point out that is not just blatantly obvious when you look at it is that it always equals 1. If you'll notice your equations at the top of page 405, they always equal 1. So it is not in standard form if it does not equal 1, and you have to force it to equal 1, okay? So that's easy. The way I force this to equal 1 is to divide everything by 48. And so that's what I'm actually going to do here. I am going to divide every piece of this by 48. And they were nice, and they gave me things that naturally divide by 48. If they didn't, we would have to do some finagling of completing the square. So I have x squared over 12 plus y squared over 16 equals 1. So now which way is this one? This is elongated actually on my y. I know that because my larger number is under my y, okay? And so that means that my a value is the square root of, square root of 16, so a equals 4. B is the square root of 12, so 2 square root of 3. And to find my c, I am going to subtract those two. So to find my c is going to be the square root of 16 minus 12, right? So my c value is 2, right? Yes? And so once again, I can find these 4 pieces. My center, where's my center on this one? Where's my center? 0, 0. Yeah. So my center is going to be 0, 0 because nothing is being added to my x and y. So my center, or my HK, is going to be 0, 0. And then I'm just having to find my vertices. My major vertices, V1, my x value is not going to change. My y is going to go up by my a value. So my x value is going to stay as 0. My y values are going to be 4 and negative 4. For my minor, it's going to be where my y now stays the same. And my x value is going to change by my b. Running out of room here. All right, and then my focus is just going to be away from my center 2 pieces. So I have my first focus. Remember now, this is going to be on the y because it's elongated this way. So it's going to be 0, 2, and 0, negative 2. All right, so when it goes this way, my y value changes for my centers, my major vertices, and my focus points. When it's elongated that way, then my minor, our co-vertices, will change my x value, okay? So I have all of those, and I'm just going to graph it. My center, obviously, at 0, 0. My major vertices at 4 and negative 4 on the y. 2 square root of 3, it's going to be somewhere in here. In between what? Square root of 3 is 1 point, so probably closer to the 3-ish, 4-ish point, little in between 3 and 4 somewhere. So we'll put that here, and we'll put that here. And then our focal points are at positive 2 and negative 2. And once again, you are just sketching. So we're just going to sketch it around that guy there. So a couple things about getting this into standard form. You have to have them grouped because we really need an x with the x squared, y with the y squared, and we need the entire group squared, which means we're going to have to do some completing the square here. So first thing I'm going to do is I'm going to rearrange this guy. I'm going to put my x's together, 4x squared minus 8x, and I'm going to put my y's together, plus 16y squared plus 64y, and I'm going to move this guy over because he's kind of in my way right now, and it's easier to just not deal with him, right? And I am going to do completing the square for both sets. I am going to group these and group these, pull out my coefficient there, my leading coefficient. Leave some room. Pull out my leading coefficient here. And we will leave some room there, and that equals -4. All right, so to complete the square here, divide the 2 in half, double it. So 2 divided by 2 is 1, 1 squared is 1. I am going to add a 1. However, if I add in 1 on one side of the equation, I need to add it on the other. Caveat. To add it to the other, that means I would have had to pull it out of my group. What is my group being multiplied by? 4. So I added a 1 in here, but technically I added 4 to this side because this is 1 times 4. Everybody see that? So if I add a 1 here, I need to add a 4 over here to account for that 1. Make sense? All right. So I am going to add a 1 there. I'm going to add a 4 here. All right. Let's look at the next piece. In order to complete the square here, I need to cut that in half and square it. 4 divided by 2 is 2. 2 squared is 4. I add a 4 here. But a 4 here is being multiplied by what? 16. So to account for that on the other side, I don't add a 4. I add a 64. Okay, does everybody see what I'm doing here? I have to account, it's a balance. I added something to this side, I have to add it equals to the other side, way back from Algebra 1, okay? So now that I've done that, I can write these in factored form. So this is going to be 4 times what my completed square was. This is going to be 16 times my completed square here. And this I'm just going to simplify, that's just 64. Now we're going to do exactly the same thing that we did on my last problem, like B, right? I need to divide everything by 64 because this must be equal to 1. So I am going to divide every single piece by 64. All right, so I'm going to get x minus 1 quantity squared over 16 plus y plus 2 quantity squared over 4 equals 1. That is standard form, and now I can do everything I need to do. I get my vertices, my major, my minor. I can do all of that at this point because I have it in standard form. The second part of this question says identify if it's an ellipse or a circle. In order for it to be a circle, C has to be equal to 0. The distance of your focal points from your center must be 0 in order for it to be a circle. So that would mean that a squared minus b squared would have to equal 0, or a and b would have to be the same thing. Okay? So A and B are not the same thing. C is going to be a number, which means a number other than 0, which means this is an ellipse. In order for it to be a circle, your distance from your focal point to your center must be 0. They must be the same thing. Those focal points must have moved all the way to your center for it to be a circle, okay? And in order for that to happen, your A and B have to be the same. So if your A and B is different, you're going to have an ellipse. If your A and B is the same, you're going to have a circle. And that's how you tell whether you have a circle or an ellipse. All right? Any questions on those?